decommissioning and maintenance. So at the end of this part of the session, you should all be able to explain the meaning of the terms commissioning and decommissioning and give a basic description of each stage of the commissioning process. Also, I want you all to be able to give a basic description of how to soundness test rigid pipe in particular. So introduction. So firstly we'll explore the terminology used in this section. So what is commissioning, what's temporary decommissioning, and what is permanent decommissioning? So commissioning is a process where a single appliance or a group of appliances are checked that they're working correctly and they're brought into use. Temporary decommissioning is when you take a system out of commission to work on it and then you recommission it so the system works again. And permanent decommissioning is when something is removed but not replaced. For example, if you removed the radiator but you had no intention of replacing it, then that would be permanent decommissioning. And in those examples, you should cut the pipe back as far as possible to remove what we would describe as a dead leg. We'll probably look at it more in sort of cold water and hot water and heating. Another example of permanent decommissioning would be if a house or a block of flats was being demolished and not being replaced. That would be permanent decommissioning. So commissioning, this is a key part of the job really. This is how the final kind of things you do to make sure the system is up and running and working correctly. So it follows a sort of key pattern, the same. Firstly, usually is as it should be. Check that all of this sort of pipes are clipped appropriately, that there's no open ends, that it basically looks okay. Then once you've checked that, you then carry out a soundness test, and that's basically to check that it doesn't leak. You know, this is for hot water, cold water and heating system. You also do a soundness test for drainage system that's slightly different. That you use air rather than the other ones you use water. You then follow up with flushing the system, and in some cases disinfecting it if for example it's a commercial or industrial property. And finally, you'd carry out a performance test, check the appliance works the way that it should do. And then once you've done that, you'd do some final checks before you hand over the appliance or to the customer. And we're going to talk about what that involves a bit later on. So the visual checks, what sort of things should we check for? Well, we check that all the pipes are plumb or vertical as they should be. Check that they're clipped appropriately at the recommended intervals, that all of the fittings are tightened, or certainly there's no obvious open ends. Make sure that you've also got around the cloth as well, so if there's any residual flux you can remove that as well. So once you've done that, you can then carry out a soundness test. So a soundness test is essentially checking that it holds water. There's a couple of different types of soundness tests we need to be aware of. One is specific for rigid pipe. So rigid pipe is basically any metallic pipework system, be it copper, steel, stainless steel, whatever. Okay, and there's also a plastic test, a plastic pipe test. It's actually two plastic pipe tests, which we'll also cover in a document which is on Moodle. So yeah, I mean, plastic pipe, things like polybutylene, MDPE, cross-bonded polyethylene. Interestingly, if you had a system that contained both plastic and rigid pipe, you should test using a plastic pipe test. So the general principles of soundness testing, well, all of the systems, whether it's plastic or whether it's rigid pipe, that should be tested initially to 1.5 times the maximum operating pressure. Okay, and you'd use a hydraulic test pump like this thing on the right here to pump water into the system to take it up to 50% more than its working pressure, designed working pressure. What is recommended is to allow the water to reach what we call an ambient temperature, and basically to allow what we might also call to allow for temperature stabilization. You should fill the system with water 30 minutes, half an hour, before you plan to start the test. So testing rigid pipe. So after you've left it for 30 minutes for temperature stabilization, we'd pump it up to 1.5 times working pressure and leave it for 1 hour. That's a test period. A test period is 1 hour. Okay. In that time, you're not allowed any visible leaks and no pressure loss. So it's a useful bit of information here, because they will ask you in later tests to work out sort of the test pressures of various systems. A good and easy way to work out 1.5 times the working pressure is you take the working pressure, you half the working pressure, and you take the number which is half, you add it to the working pressure, and that gives you 1.5 times the working pressure. I mean, for example, if you had the working pressure of 2 bar, half of 2 is 1, so you add the 1 to 2, which would then give you a test pressure of 3 bar. Okay, again, for example, if you had a working pressure of 10 bar, half of 10 is 5, so you take the 5, you add it to the 10, that gives you a test pressure of 15 bar. Nice and easy, always comfortable to work that out every time in your head, no problem. Okay, so systems can there's 2 tests for plastic pipes, test A and test B, and I've actually sort of created a flow chart to describe each one in Ease-On or Moodle. Okay, so both during and after soundness tests you would check for leaks, and once you know that it's all solid, it's holding water, you can then sort of do some of the final stuff like adding insulation and sort of flushing the system. Okay, so flushing, this is essentially to remove any debris that might have ended up in the pipework. Okay, so you fill up the system with water. It's already filled up with water from the soundness test, and you just let that water all flow out, and that should take a lot of the debris out with it. Okay, generally speaking, in a domestic property, you just flush it with wholesome water, just with regular water from the mains. Okay, for industrial, if you did disinfect, use disinfectant, you need to make sure that you talk to the water supplier before you release that water out into the sewage system. So basically ask and let the water supplier know this is what you're doing, and get advice before you carry it out, before you do the disinfectant, and certainly before you release that water out into the drainage system. Okay, so flushing heating pipes. Yeah, I mean, one sort of key bit of information, once you've flushed heating pipes, you would then sort of, just before you fill up the system for the last time, you should add an inhibitor to it, and that inhibitor is there to sort of prevent corrosion, essentially. Yeah. Another interesting bit of information about flushing. On heating systems, over time, even if it's got inhibitor, and the inhibitor is there to inhibit, prevent, or reduce corrosion. But even if it does have an inhibitor in it, over time there will be corrosion inside the heating system. So every so often, very, very occasionally, you might need to get your heating system power flushed to remove that sort of corrosion, sort of, we call it sludge. But yeah, it's iron oxide that's corroded from the inside of the radiators. Performance testing. So once you've finished your flushing, you then give the system a final fill, check the installation works. Okay, how you do that would depend on what system you're working on. Like, for example, on hot and cold systems, you'd always want to be checking the pressure and the flow rate. You can check the working pressure and the working flow rate, which essentially is sort of the if you open up all of the taps, the pressure is going to be different, the flow rate is going to be different at each tap than if you just open up one tap at a time. Okay, so generally you'd want to performance test under what we call maximum demand, which is when all our taps are open, and then you can sort of check the flow rate at the outlets. Okay. On hot and heating systems, we'd also be wanting to check temperatures, and you can do that by using a thermometer. You can see here using a thermometer to check the hot water temperature. You can also use sort of clip-on thermometers, or more recently these modern, I'm not even sure what they're called, but there's electric sort of diodes which go onto the strap onto the heating pipes, and it tells you the difference in temperature between the flow and the return. A differential thermometer, I think it's called. Okay, so where can you find further information on commissioning? Well, in the installation instructions. And these would contain a number of things that should be checked, which would be included in the benchmark commissioning checklist. And once you've carried out the installation and you've commissioned it, you should fill out this commissioning checklist as you go, and make sure you give it to the customer at the end of the job. So when you give the customer all of the relevant paperwork, you should also verbally explain the controls to them before you finish up. And also it'd be sensible to let them know of the future maintenance requirements of the installation as well. Generally speaking, most things need to be maintained every year, every 12 months. They're recommended to be maintained. So it's sensible to sort of make sure you let the customer know that. Maybe put some sticker on the piece of work with your number on it, saying sort of recommended to be inspected yearly, and with your phone number on. Okay. All right. So now it is time for your task.